Hello everyone, it's Ott, and today we're going to be exploring a physics blunder in the movie Up. For those of you who don't know, Up is a movie about an old man that seeks to live out his since-dead wife's dream of reaching Paradise Island. He achieves this by doing this. I know, pretty crazy. Now, before we discuss the feasibility of lifting a house with balloons, there are some details that I want to omit from my analysis. As you could see, the house was ripped from its foundation. I will simply be discussing the balloon's effect on the house only. This by extension also excludes the weight of the string. As we know, there exist hot air balloons that are able to carry a payload. So why can't we lift a house using this concept? Well, we can, except in this particular animation, there are not enough balloons portrayed to be able to lift that specific house. Let's see how we could find out how many balloons we actually need to be able to lift a house of this size. The concept that applies here is Archimedes' principle, which states that if an object is submerged in a fluid, then the buoyant force acting on it is equal to the weight of the fluid displaced by that object. We could use this concept to figure out the amount of balloons we need to lift the house. Let's take a look at the system we have here. As you could see, the buoyant force is pulling the system upwards, and the gravitational force of the house and the balloon are pulling it downwards. What we want to know is how much helium, aka balloons, are needed to have this system achieve lift. To do this, the system has a net force of 0, since there is no acceleration, and we could set it up like this. We then expand it to get the density of air times volume of helium times gravity minus mass of the house minus density times volume of the helium times gravity. Since all the terms have gravity, we can cancel it out and get this. Now we do a little bit of simplifying and we end up with this, where we solve for the volume of helium. Here we have one question we have to ask ourselves. How much does the house weigh? Well, according to Dawson Foundation Repair Construction Company, a house similar to the house in Up weighs about 275 pounds per square feet. As it turns out, there exists a real replica of the house in Salt Lake City, in Utah. This house has an area of 2,800 square feet. Now remember, we are not including the foundation into our calculations, meaning we have to subtract that out. The average foundation weight of a home this size is about 200,000 pounds. Thus, we can conclude that the house in Up weighs 570,000 pounds, or about 258,547.65 kilograms. Given this information, we have everything we need to solve for the volume of helium. Air density is 1.225 kilograms per meter cubed. Helium density is 0.1785 kilograms per meter cubed. We could plug it in and it comes out to 247,059.39 meters cubed. So how many balloons is that exactly? In the movie, we can assume that the old man uses average 12-inch party balloons, which hold a volume of helium equal to 0.523 cubic feet, equal to 0.014809 cubic meters. We divide this amount by the volume of the total balloons in the system, and we get that in order to lift this house with balloons, we would need around 16,683,056 12-inch latex party-style balloons. Now, you may ask yourself, how does this compare to the balloons portrayed in the movie? Well, according to Pixar, 20,000 balloons were animated in the lift scene. 20,000 is significantly less than 16 million balloons. To put this into perspective of what this might look like, here is a real video of 1.5 million balloons launched in Cleveland. In conclusion, although a very possible feat, Old Man Carl would have needed 800 times the amount he had in the movie. In reality, Carl probably would have never been able to fly to Paradise Island. And oftentimes, the reality of movies is often disappointing. This has been the flaws of lifting the house in up. Bye.